All right, so I've set up a little circuit here to show the operation of an oscilloscope. What we've got is we've got a 120 volt supply coming into a transformer. Coming out of the transformer, we have a 28 volt secondary, 24 volt under load, but when it's open circuit, puts out about 28 volts across the whole secondary. And it's a center tap transformer, so we're going to be applying 14 volts AC into this circuit. Coming out of one side of the transformer, we go through a diode. Coming out of the diode, we go to this little resistor, back out of the resistor to the center point of the transformer. So we've got a half-wave bridge rectifier with roughly 14 volts AC being applied. So we've got our reference point set up as the one side of the transformer. That's this little clamp here. Channel 1 on our scope is monitoring the output of the transformer, and channel 2 is going to measure the voltage drop across the diode from the transformer. So when we turn on channel 1, you'll see we get the nice AC wave coming out of that secondary of the transformer. Now with the oscilloscope, you can change the scale, so you can make that wave shorter or taller, depending on what you want to see. You can see we've got, you probably can't read it, but we've got a frequency of 60 hertz, a peak-to-peak voltage of 41.6, and a maximum of 20.8. So that's your peak value on one side, and an RMS value of 14.7, as I said. So channel 1 is seeing that output coming across coming out of the transformer. When we turn on channel 2, it shows up in blue, and now this is the voltage drop across our diode. Okay, so our diode, our head end of the diode, with respect to the transformer, this is negative with respect to our reference, right? That's why we're seeing the wave on the downward side. And you'll see that it's inverted from the sine wave. You'll see we get kind of an ellipse everywhere. That's because they're referencing, these two leads are referencing from opposite ends of our opposite sides. We can invert that right here, and that'll make so this is more representative of what's actually happening. So as the diode is reverse biased, it blocks that voltage, and we see a voltage drop across it. And then when it's forward biased, there's only 1 volt dropped across our diode. You'll see that blue line is just below the center point on our grid, and this voltage here, that bottom blip, is what's actually getting through to the resistor. One of the nice things with an oscilloscope is we can change these, we can change the scales independently. We can also move them up and down so that we can get a better view of the wave, right? So they're not one on top of each other. And actually move that so they're up and down. We'll put them back to original spot. And that's the operation of the oscilloscope. Okay.